So now we have, actually I think yes, it's Claudio Pisa now, I forget what to say. Okay, so the presentation of Claudio is about monitoring using Grafana, so no check left behind.
Okay, hello. My name is Claudio. I work at GARR in the Distributed Computing and Storage Department. What is GARR? GARR is the National Italian Research and Education Network. That is a non-profit organization which is connected to GIANT, which is the Pan-European Research Network. Talking about the physical network, we have a high-speed network which connects more than 1,000 locations. We have an estimated 4.5 million users, which include teachers, researchers, students. 15,000 kilometers of optical fiber and 380 petabytes of yearly traffic. The logos that you see on the bottom are the founders of the consortium, that is of the association. So, coming to the distributed computing and storage part, we have 5 data centers which are located in southern Italy, which, let's say, altogether have about 9,000 cores and 10 petabytes of storage. Okay. How do we manage this infrastructure? We do this in an automated way using mostly Ceph and MAS with Juju as an orchestrator. And with Juju and all the tools, we manage the GARR cloud, which is based on OpenStack, which has about 600 users, more than 1,000 VMs, and 3.5 kilo cores and 9 terabytes of RAM used, 1 petabyte of storage used, and about 900 IPv4 in use right now. And also, with the same tools, that is with Juju, we manage the container platform, which is based on Kubernetes. It's a bare metal cluster. This allows us to use the GPU, and we have made this cluster multi-tenant. Okay, so we have the same cluster for all the users. Okay, what is Juju? Juju is a software tool that is used for the deployment, configuration, and management of services on clouds. But not only. Together with MAS, we can manage also physical servers. It's free and open source and allows the user to use a high-level declarative language. So the user doesn't have to really get into the details of what it's doing. Just specify what the user wants to do, not how. The basic concept of Juju is the one's charms, which are basically script collections, which can be written in any scripting programming language, and many charms are collected in the Juju store, which, despite the name, provides free charms. And Juju orchestrates the deployment, composition, and scaling of charms. So this is Juju. So 1 year ago, I was hired by GARR, and I was, let's say, put in charge of looking into monitoring. And at the time, there were 2 monitoring systems in place, which were Nagios for OpenStack services, and Zabbix for Ceph and other hardware. And also there were some systems that were outside these monitoring systems. So on day 0, the architecture was more or less this one. We had the Nagios and Zabbix. Nagios was monitoring the cloud infrastructure services, while the Zabbix was more looking into Ceph and the actual physical infrastructure. and each one had its own web interface. So you had to log into different interfaces, into different websites, let's say, to understand what was going on. And also there were other web interfaces we looked into. Like for example, we looked into the Dell IPMI, or we looked into the genes monitoring system, which is the monitoring system in GARR, which takes care of the networking part. So the objective was to build a unified dashboard for everything. Okay. And how do we do that? Grafana, okay, which is the state of the art. Why Grafana? Listen, some considerations. So before, let's say, diving into this, let's say that the existing monitoring systems seems to be doing their job quite well. They seem to be the right tool for the right job. What was missing is just a single viewpoint. And Grafana seems to be the right tool. So Grafana is a platform for data visualization, querying, and alerting. It has this thing, that it has several pluggable data sources which are very heterogeneous. It can plug into Zabbix, PNP, which is Nagios, Prometheus, Gnocchi, Monasca, JSON, whatever JSON, whatever MySQL. So you can mix all together all the data from different sources on the same dashboards. Okay. So the architecture that I proposed was this one. Put all the monitoring systems under Grafana. So the tools were in the right place, where the monitoring tools were doing their job well. So we just needed a unified visualization. So integrating Zabbix into Grafana was quite straightforward. Zabbix is a monitoring tool which has everything included. Okay, you usually don't install plugins in Zabbix. It has nice auto-discovery features. It has XML-based templates which can be reused for similar systems. It has remote agents and has a very good Ceph integration, and also multi-user support. So the integration with Grafana was easy because Grafana has a Zabbix data source that just plugs into Zabbix, and this is a screenshot of what we got. These are, I don't know if you can see it, I don't think so, but on the left we have a Ceph cluster which is in Palermo, reads and writes, and sectors written, sectors read. And on the right, a similar cluster we have in Catania, which is also heavily used. So we can see this in Grafana. And then Nagios. So Nagios is a free and open source monitoring tool. It has this concept of plugins, which are basically scripts which report to the core of Nagios. And it has this remote plugin executor. That is, if you have an host that is remote and you want to see the internals of that host, you can use an RPA. Nagios is known especially for alerting, not for metrics. But we can see how we can overcome this. So in the official pack, there is this one. How do you pronounce Nagios? So the author pronounces it as Nagios, but you can pronounce it whatever the heck you like. And the author says it Nagios. Okay, so Nagios has this advantage, which is very well integrated with Juju. There is this Nagios Charm, which is Nagios Charm, which is supported. It has this NRP charm for remote hosts, and usually canonical OpenStack charms have already configuration options for Nagios. So it's very easy to use Nagios with Juju, for OpenStack at least. So if we use PNP, we can augment the Nagios to store metrics. Okay, so the plugins of Nagios can not only report if a service is up, if everything is okay, but also can get performance metrics. So most plugins are already ready for this. Even the ping plugin already has some timing. And with PMP, we can store this information into these round-robin databases. And there is a PMP Grafana data source. So we can plug this into Grafana. And the other thing is that we wanted to monitor what was happening inside OpenStack, not only outside. We monitor the OpenStack services with the Nagios Charm, but we don't know what's happening inside OpenStack. So we wrote a set of Nagios plugins which collect metrics from the OpenStack API. So they query the OpenStack API and put this into Nagios, that is into PNP, and then into Grafana. What we collect is, for example, number of projects, number of servers, floating IP address usage, volume usage. Also, as a side effect, the OpenStack API reachability and stuff like this. Okay. And with this, we can build a dashboard which looks like this. Okay. So we have, for each region, different gauges that say how many CPUs we have, how many RAM we have left. We have some problems with IPs. So we will have to move to IPv6 someday, and all the rest. And also we can check the status of all services with interfaces like this. Then, at some point, a new guest came to our house, that is Kubernetes. And we had this thing. So you all know, I think, Kubernetes. It was inspired by Google Borg. So there is this thing called Prometheus, which is an open source monitoring tool, which is inspired by the Google Borg monitor. Okay. So it has a powerful query language and some advantages, like alerting built-in and white box monitoring. That is, you can see what is going inside applications. And there is also that Kubernetes supports Prometheus natively, and Grafana supports Prometheus natively. So you will be assimilated by the Borgs. Okay. So the new architecture is now with the Prometheus plugged into Kubernetes that is also into Grafana. And you can have a dashboard like this in a very short time. That is, you install Prometheus basically inside Kubernetes, and then you instruct Grafana to use that Prometheus. Very easy to deploy. And so we are looking into Prometheus. So the thing is, Nagios has some disadvantages. That is, it has no query language. When you use it, especially with Grafana, there is no, you cannot do complex queries. But it's very easy to develop new plugins and do what you want to do. So you move the script, you move the language from the query to the plugins, which is not the same thing, but it depends on your use case. And also this thing of using RRD, which is a quite ancient technology. It's okay for our use case, but for highly dynamic environments where things come and go, it's not really the best thing. For example, for cloud native applications. But it's okay for our use case. So one thing that I noticed is that the performances change a lot with Grafana. That is, the time to render graphs is very good if we use Nagios PMP. It's okay if we use Zabbix, and can be quite slow when using Prometheus. It depends on the query that you are querying, on what to visualize. what we want to do in the far future. Self-healing. So the monitoring system should be able to react to well-known bugs which have not yet been fixed with well-known types, and then wait, okay? So that you don't get into a healing loop. Okay. We're working on this, so it's not that far in the future, but this one is quite far. That is iOS. Okay. So the idea is to collect many metrics, many. Then annotate whatever happens, incidents, events, whatever happens in your world, and then train an AI to use the collected data and understand when something is going to break or something. So there are companies actually working on this. It's not science fiction. Okay, and then profit. Okay. And then we will build the Skynet. Okay, that's all. Thank you.